Good afternoon. My name is Peter Langham. I'm the Domain Chapter Lead for Data Engineering and Data Science at Spark New Zealand, and I'm fortunate enough to have the opportunity to talk to you a little bit about our cloud migration journey, and in particular how Snowflake fits in as a key component of that. Now, this is a presentation that would normally take about an hour, so I'm going to try and condense it down for you into about 25 minutes. Let's see how we go. So to start, we need to rewind a couple of years and have a look at where we were coming from. So this picture shows a snapshot of our legacy data landscape. And as you can see, it's one that's fairly fragmented. So a number of different systems that we're using, both in terms of data repositories and also the BI tools that we're using for analytics and reporting. To quickly run through some of the key systems that we had, for anyone who's worked at Spark or Telecom over the past 25 years or so, might be familiar with a system called Probe. So that was our legacy Oracle-based data warehouse. It had survived several attempts to decommission it and was still being used for a number of business critical functions. Our more recent enterprise data warehouse, or EDW, that was established as part of Spark's re-engineering program, had been built basically as a single platform to support enterprise reporting across Spark, and that was housed on an IBM DB2 appliance. At the same time, we also stood up an IBM PDA appliance, or Pure Data System for Analytics, which was being used for those resource-intensive analytics workloads. And we'd also leveraged for high volume data ingestion and aggregation, just to reduce the load on our data warehouse. More recently, we'd also stood up an on-premise Hadoop cluster, again being used for those big data and analytics type workloads, and also acting as an enterprise data lake for long-term storage of those high volume data sets. Now, we were facing a number of challenges and I guess a number of drivers to look to do things a bit differently. One of the key ones being that those IBM appliances were actually reaching end of life, and they were also reaching their capacity, and due to the appliance nature of them, were unable to be scaled. Our on-premise data lake, probably a victim of its own success, was also nearing capacity. So we'd seen a significant volume of data loaded in there, and it was becoming apparent that we would need to continue to scale the hardware on an ongoing basis to meet demand, and that was going to be time consuming and costly. Of course, we also had multiple systems involved, meaning data was spread across those various different systems, often duplicated, and creating a challenge for analysts trying to use that data and stitch it together, as well as the risk of inconsistencies and data quality issues. User contention was certainly a challenge, especially during peak times, so month-end reporting, for example, and also that overlap with the overnight batch windows where we'd be doing our ETL processing. Like most organizations, we'd seen a massive growth in the amount of data actually being used across Spark. So that's data that we're capturing and using for analytics. So we knew that we needed data platforms that could easily scale, both in terms of storage and compute, to cater for an increasingly data-driven organization. We had very significant ambitions around what we wanted to do with machine learning and AI. And again, it was apparent that the legacy platforms we had weren't necessarily well suited to meet those ambitions. And we could see what was coming. So with the rollout of the IoT and 5G networks, we knew there was going to be massive new data streams coming in, which again, we weren't well set up to be able to accommodate. So what did we do? At that point, we decided the best approach was to complete a holistic assessment across our full data and analytics capability in our existing landscape. So rather than focusing on just what do we want to do with our data warehouse or our data lake, it was really to look at that full end-to-end architecture. Of course, as part of that process, we engaged multiple vendors. Without going through a full list of names, that certainly included all of your traditional enterprise data players, as well as the big data offerings, and of course, the more recent cloud services. The various capabilities were of course evaluated and compared, and it quickly became apparent to us that moving to the cloud was a must to get the kind of scalability and elasticity that we were looking for. As part of that, we then had unanimous agreement across our data architecture team that Snowflake was the right choice for us as our common data layer as part of a broader Microsoft Azure-based cloud architecture. I'm sure most of you are at least somewhat familiar with Snowflake, but just very quickly, it is a fully managed built for the cloud data platform, so a full SaaS offering. And the key point there for us being really the scalability and separation of compute and storage that it allows. So its ability to deliver on that scalability and elasticity. To go through some of the features, I guess, that led to our decision to go with Snowflake. So simplicity up the top there was really a big one, and that takes a number of forms. So I mentioned there simplicity in terms of automatic optimization, so no need for indexes or partitions, but also simplicity around the administration, the deployment, so everything that comes along with that SaaS product. Performance and scalability, obviously, as I mentioned, is a key one. And scalability, not only in terms of being able to accommodate a large amount of data, but being able to also work with data at all different sizes. So not all of our use cases, of course, are looking at those real big data volumes. A lot of them are more just traditional data warehousing type use cases. So it's really important for us that we could actually include data that came from right from just a few rows through to that real massive scale that we're looking at with, as I mentioned, some of those new data streams coming in. Backup and recovery I'd include as part of that simplicity theme. So the features that come automatically bundled with Snowflake really simplify that whole process. Elasticity, I'll touch on this a bit more later, but that's really both that vertical elasticity to be able to scale up, but also horizontally where we're seeing that high concurrency in terms of usage. Separation of workloads is a really key one for us. As I mentioned, we were seeing that user contention, so the ability to completely separate out what we're doing with our ELT processing versus what we're doing in the machine learning space versus our typical sort of business use through Power BI, really key. Data sharing was one that was really appealing to us. So as an organization, we certainly do a lot of both internal and external data transfers. Of course, at the moment, that typically involves a lot of different integration tools, flat files. So the secure data sharing capability with Snowflake was a really attractive one to us. And again, cost obviously was a factor. So not only the cost of the service itself, but also the lower admin costs that come along with it was really a consideration as well. So where are we moving from and what are we aiming for? So look, this really talks about the vision that we're aiming to achieve. Obviously touched on the fact that previously we had a number of different systems creating those data silos, duplication of data and issues with multiple versions of the truth. Our aim is to have a single cloud-based common data layer. Again, obviously talked about the move to unlimited scalability and elasticity, particularly important when we're talking about the AI and ML type use cases. Another key one is really around timeliness of data. So moving from data that is at least 1, sometimes 2 days old, to real-time data flows by default and embedding that in automated decision-making workflows. Getting away from those user contention and performance issues that I mentioned to having that dedicated compute. Again, moving away from a world of high operational support overheads to a very low maintenance PaaS and SaaS-based platform. High availability and resiliency is a important one as well. Obviously, the platform resiliency as well as things like security and privacy are really important for us. So moving to a highly secure and resilient platform was extremely important. And of course, the cost question again, so moving to that low-cost cloud storage and also a new cost model where you're only paying for what you use, which as I mentioned in an upcoming slide has resulted in some significant savings for us. So what does the future look like? This is probably a really key slide to talk about, I guess, what we are doing fundamentally, and that is moving away from the idea of having a separate data warehouse, data lake. At the moment, we've got separate operational ODSs in different domains. We've got a dedicated data quality database to having a common data layer that can serve all of those different requirements. And built obviously on Snowflake as the underlying technology. Now, of course, there still is a requirement to have those different functional areas. And as you can see, this is then represented as different layers within our overall unified data platform. First of all, we have a real-time replica of a number of our enterprise systems, and that's there to serve those real-time use cases. So whether that's getting a real-time view of customer product holdings, open orders, interactions, whatever it may be. That then flows through into a full historically tracked source aligned layer. So that's basically all of our data in a raw format, available for use for data analytics and machine learning use cases, but also available there as a persistent source aligned store. The presentation layer then is, I guess, typically what we'd consider as a data warehouse. So that's where we have those curated, trusted data objects aligned to our business definitions and usage, and available to support that enterprise reporting and analytics. Of course, increasingly, our use of data is not just in that data warehouse type use case, but getting into more machine learning and AI models. So that's where the analytics foundation is really important. That's essentially our feature store, where we model common analytic features for reuse across those models. And finally, once we have generated scores, segments, characteristics from analytic models, we'll also capture those results back into the common data layer as well, so they're available for others to consume. Touched before on scalability, and that's a really key thing that we're enabling with Snowflake. So I mentioned the idea of having dedicated compute, separate virtual warehouses, meaning that our ELT can be completely separated from our visualization and similarly from our data science workloads. So no more contention, and look, this is really a nirvana state, I think, for people who have been in the BI and data warehousing space for a while, removing that contention between our scheduled ELT processes and our user queries. Ability to scale up. So this is a key one in our advanced analytics and machine learning type space. So the ability to get a performance boost where we've got those really resource intensive but relatively short duration type workloads. And equally important, the ability to scale out. So this is where we're seeing a high amount of user concurrency around month-end reporting time, for example. We don't necessarily need that scale up, but we just need the ability to accommodate that increased number of users. And finally, the low-cost storage, built just on Microsoft Azure Blob Storage, which means that we can actually accommodate those significant data volumes that we're seeing at a significantly reduced cost compared to our legacy technologies. Ties in well to the overall reduced TCO. So obviously the cloud model is a different paradigm. So it's not necessarily a like-for-like comparison, and this is based on our estimates and forecast usage. But from what we're seeing at the moment, it looks like around about a 75% annual cost saving that we'll be seeing compared to our legacy systems. Again, I'll only quickly touch on this one, but really important for us, obviously, is making sure that anything that we're delivering is highly secure, meets all of our privacy requirements, and has that high availability and resiliency built in. As part of our assessment and design process before we deployed anything, we had to go through some rigorous internal reviews around our security and privacy, and the features that are available with Snowflake and Microsoft have made it relatively straightforward for us to be able to deliver to all of that. So for example, having data that's encrypted both in transit and at rest, having a dedicated private network route end to end, and of course the high availability that comes bundled as part of these products, and the ability to have data replicated. Data in real time, as I mentioned, timeliness of data is a really key one for us. So what we are doing is moving to a world of batch-based processing to data ingestion happening in real time by default. So that includes both data which traditionally we've received in real time, so real-time streams, network data, for example, but also our traditional RDBMS-based sources. So using CDC to actually get a real-time stream of that data as well. Of course, that results in a number of benefits for the business, being able to have that live performance tracking across our business metrics, having a current view, for example, of our customer profile to empower our frontline agents and enable precision marketing, being able to embed those real-time streams as part of analytic workflows and ultimately leading to automated decision-making. And finally, just one point to mention, through the use of Kafka as our message queue, it also means that as well as feeding data into our data platforms, that data can also be consumed by multiple applications downstream. Unlocking machine learning at scale has been a really key one for us. So over the past couple of years, we've also been going through a rapid, I guess, maturity uplift within Spark in our data science space. Up until now, it has been mostly individual initiatives, individual models that we've been deploying, but we're now looking to the next level of how do we roll that out and deploy that at scale across the organization. So both in terms of the customer understanding and deep customer insights, which has been our focus to date, but also then looking at the network experience. How do we actually deliver that superior network experience for all of our customers across New Zealand? In the product space, how do we help to accelerate what we're doing around product simplification and migrating off legacy technology? And of course, again, in the marketing area, how do we deliver a seamless and personalized multi-channel experience online and offline? And how does this show up for users across the organization? Obviously, we've got some different personas. So for business users, I guess a key one is going to be around the timeliness of data as mentioned. So rather than data that's 1 or 2 days old, having a much more up-to-date view of it. Having a common trusted source is a key one as well. And of course, the great performance that they'll be seeing, whether it's querying Snowflake directly or through Power BI, which is our enterprise standard visualization tool. Data analysts, massive benefit they're going to see is no longer having that need to stitch data together across multiple systems. All the data is going to be together in a common data layer, so they're going to be able to spend more time using that data and less time trying to find the right data to use. Removing that contention, as mentioned, is going to be a game changer, and also the ability with Snowflake to work both with structured as well as semi-structured data in a native way. Data scientists, really the massive step change they're going to see is going to be around elasticity and scalability. So the ability to have their own dedicated compute, which they can scale up for those resource-intensive ML processes, and also that scale to be able to handle the massive volumes of data that they're dealing with. And finally, around leadership, again, timeliness, trusted data sets, and also one that I'll mention in a second, but bringing together all of the various Spark brands into a common view. Operations are going to see some significant changes and some major benefits as well. We're going to be consolidating multiple legacy systems into this common cloud-based unified data platforms, significantly reducing our operational overhead. No more need to manage our own hardware and infrastructure. No more requirement for database tuning, indexes, partitions. We don't need to worry about software updates and deployments. No more desktop applications, and of course the automated monitoring and auditing that comes through our use of Azure as well. Of course, at Spark, we do have a multi-brand strategy, and this is really the first time that we're looking at how we bring together this data from across our brands. So this is something that previously we hadn't attempted, and again, really this common data platform and the use of Snowflake is unlocking that ability for us. And also looking beyond Spark. So as I talked about earlier, how can we look at secure data sharing, whether that's with partners, suppliers, customers, any other organization where we have a need to share data. Now, previously, that's something that we've had to do in a variety of ways using different tools, different file sharing techniques. The use of Snowflake's secure data sharing capability really just makes that simple and safe and secure, which is ultimately what we're trying to achieve and moving away from those file transfers. So how are we going with delivering the future? Obviously, this is a massive undertaking. To even get to the point of starting any build activity, we had to go through numerous stages of security and privacy reviews and funding and everything else. So even to get to the start line was an achievement in itself. Since then, we've made some awesome progress. A massive milestone was the day that we actually fully decommissioned our legacy data warehouse probe. We've also now fully migrated all of our production workloads off our PDA appliance. The migration of our enterprise data warehouse and our data lake is progressing well. Given the size of them, obviously they're major initiatives in their own right, and they are being progressively migrated on a subject area basis dependent on the business priority. All of our new initiatives are now running fully in the cloud. We've stood up our CDC capability that's been successfully tested. We'll have our first data source productionized this quarter. We have established a Snowflake data sharing capability as well. First use case there was sharing between Spark and Spark Sports. And the verdict, I think it's unanimous across all of our, whether it's data engineers or analysts, everyone loves Snowflake, the simplicity of it, the performance they've seen. So yeah, look, a massive thumbs up from us. Hope that was useful. Best of luck to everyone out there with your own cloud journeys. More than happy to continue this conversation and share what learnings we've had over this journey with anyone. So please do feel free to get in touch. Thank you.